I'm Mr. Laidan, and today we are going to determine isotonicity by sodium chloride equivalent method. The concentration of sodium chloride is somehow equal to the concentration of body fluid, meaning that any substance with a concentration equivalent to that of sodium, at least it shall be isotonic with body fluids. So the sodium chloride equivalent method, or the sodium chloride equivalent, this is the amount of sodium which has the same osmotic effect based on the number of particles as 1 gram of a drug substance. This is summarized as follows. Sodium chloride equivalent, it is briefly written as E and sodium, natrium. So the sodium chloride equivalent is equal to the amount of sodium, meaning amount of gram, which can produce the same osmotic effect with the same osmotic effect as 1 gram of a drug substance. So all calculations we are going to perform here are intending to do this, to find how much sodium chloride is equivalent, or how much sodium chloride can produce the same effect as the effect produced by 1 gram of a drug substance. A drug substance can be ephedrine, boric acid, adrenaline, and whatever drug substance which you are going to see. So we are going to look at the equivalence. How much can produce the same as 1 gram of a drug substance? So take note, all of it is about the amount of sodium in grams. So we have several formulas, but before I narrate them down, you need to remember that as we did in the previous session in the freezing point depression, also here in sodium chloride equivalent, we are going to use the same approach, but the unique stuff here is the table of figures. Previously, we had a table on freezing point depression of common substance. And in this sense, we are going to have another table of sodium chloride equivalents of different drug substances, which were calculated when the concentration of such drug substances was 1. And if it was 1, if it diverges or if it deviates from 1%, then we need to multiply the concentration by the given sodium chloride equivalent to get the actual amount of sodium chloride equivalent. So let's do it. So that is the table. As you can see, the table of freezing point, the table of sodium chloride equivalents, that is easily seen. And that is abbreviated as E. You can see we have ammonium chloride. The E, the sodium chloride, its sodium chloride equivalent is 1.08. All right, so meaning 1.08 grams of sodium can produce the same osmotic effect as 1 gram of ammonium chloride. If boric acid has got sodium chloride equivalent of 0.52, this means that 0.52 grams of sodium chloride can produce the same osmotic effect as 1 gram of boric acid. That is a simple proportion. Now let's go to check some examples. When you do this, to perform this, there are about 3 steps. The first is to find how much sodium is needed. So, steps of solving these questions, memorize general 3 steps. The first step is to find how much sodium chloride is needed to render the formulation isoosmotic. And this is obtained from the concentration of sodium chloride, which is 0.9%. Then, number 2, you need to find the amount of sodium chloride represented by the ingredients. The amount of sodium chloride represented by the ingredients, this is the sodium chloride equivalent. So number 2 determines the sodium chloride equivalent. Then subtract the total value obtained in step 2 from the amount of sodium chloride required to render the formulation iso-osmotic. So in step 3, you need to take what you got in step 1 minus what you got in step 2 to get the actual amount of sodium chloride. Let's do it. For instance, we have the following prescription, as you can see. It says, find the quantity of sodium chloride required in compounding the following prescription. The sodium chloride equivalent of cocaine hydrochloride is 0.16. So, what are the ingredients? We have cocaine hydrochloride. Okay, here we have cocaine hydrochloride, which is 0.2. And if it is plain, that is the percentage, that is in terms of percentage. Then we have sodium chloride here, sufficient quantity. We are going to calculate this, we don't know this. Purified water, we need to add water up to 30, that is 30 mils. And according to the instruction, you need to seek one drop in each eye. So we need to render this isosmotic. This solution is not isotonic, so we need to add something to make it isotonic. So the adjusting substance here is sodium chloride. Why? The question says find the quantity of sodium chloride, which means we're going to use sodium chloride equivalent. Alright, so what is the first step in this? And we have been told that the sodium chloride equivalent of cocaine hydrochloride is 0.16. This can be obtained from the table. So step 1, find how much sodium is needed. So sodium can be calculated from its concentration. 0.9 means 0.9 gram is in 100 mils. Then how much is in 30? How much is in 30 mils? Then that is equivalent to 0.27. Step number 2, find the sodium chloride equivalent. So this is the sodium chloride equivalent of the ingredients mentioned in the solution. What is the main ingredient here? This is cocaine hydrochloride. So its percentage is 0.2%. This should be multiplied by its sodium chloride equivalent from the table of sodium chloride equivalents, which is 0.16. So this is 0.2 times 0.16. This is 0.032. After obtaining 0.032, step 3, subtract what you got in step 2 from that of step 1. So take 0.27 minus 0.032, you'll get the actual amount of sodium chloride. This is 0.238 grams. Okay, so the amount of sodium chloride required to make this solution iso-osmotic with body fluids is 0.238. How do you do it practically? So first, you need to weigh 0.23 grams of sodium chloride, put it aside. Therefore, find the actual amount of cocaine hydrochloride here. After getting the actual amount you weigh, put it aside, then measure the required amount of water, then mix both, stir well, then the preparation is already iso-osmotic. Okay, the next concept here is like this. This is very important to know. In the previous session, when we were talking about the freezing point depression, we said here the values should be in terms of concentration, in terms of percent. in terms of percent, but when you are using the sodium chloride equivalent, the values here should be in terms of quantity, not percentage strength. So let's check this example. Suppose compounding this prescription, you have epinephrine. Let's consider this. This is a solution of epinephrine 1%. Then you have scopolamine. You have scopolamine 0.5%. Then you have sodium chloride. This should be in sufficient quantity, which you are going to calculate. Then water for preparations, you need to add up to 60 mL. So make this solution iso-osmotic with body fluids. In simple ways, this is unadjusted, meaning it is not isotonic with body fluids. We need to adjust it by using sodium chloride, which is the adjusting substance. As the question says, find the quantity of sodium chloride to be used in compounding the following prescription. Now, the sodium chloride equivalent values of epinephrine, hydrochloride, and scopolamine are as follows. Epinephrine, its sodium chloride equivalent is 0.29, and scopolamine, its sodium chloride equivalent is 0.12. The figures of sodium chloride equivalent, as I said, are obtained from the table as displayed before. So the first step, what do you do? First step is to find amount of sodium chloride to be used. How do we find this? It's from its original concentration. This is 0.9 is in 100 ml. So how much is in the total preparation of 60 ml? This is equivalent to what? Take 60 divided by 100 times 0.9. This is 0.54 grams. That is the amount of sodium to be used. Then step 2, find the sodium chloride equivalents of the ingredients in the preparation, epinephrine and scopolamine. Okay, how do you do it? You take the quantity in grams times its sodium chloride equivalent. Mind you, here we have got 2 ingredients, so we need to find the equivalents for both, then we sum them up. So, but in this case, we have not been given the quantity in grams, instead the percentage strength. So when dealing with sodium chloride equivalent, make sure these are in grams. How do you do it? Okay, 1% means that 1 is a proportion of 100. So how much is in 60 ml? So this is 0.6. Let us prove by using our scientific calculator. This is 0.6. So the actual amount here is 0.6 grams. Then take 0.6 grams, multiply by its equivalent. Then about scopolamine, this is 0.5 is in 100 ml. Then what about 60 ml? Probably that is 0.3. Let us prove our answer. 3 over 100 times 0.5, that is 0.3 grams. So this is for scopolamine multiplied by its sodium chloride equivalent. What do you get here? So the first was 0.6 times 0.29. This is 0.15. Then add the next. This is 0.3 times 0.12, its equivalence. That is 0.036. The sum gives you 0.15. This is 0.186. So This is the total ingredients, the total sodium equivalence of the ingredients. Step number 3, subtract 2 from 1. Then that is 0.54 grams minus 0.186. Then you get 0.354 gram. So this is the amount of sodium chloride required to render the following solution isosmotic. What you will do is to weigh 0.2 grams of epinephrine, then weigh 0.3 grams of scopolamine, then weigh 0.354 grams of sodium chloride, then dissolve them in a solution, make a solution to be 60 ml, stir all the mixture, then that is already iso-osmotic with body fluids. Let's check the final concept on this. So what if you are dealing with other tonicity agents other than sodium chloride? What if you are going to use the other substance to adjust the isotonicity or the tonicity of the substance or the solution if it is not sodium chloride? Let's say you are going to use boric acid to adjust an unadjusted solution to make it isotonic. What are you going to do? So the procedures are the same, but one more additional step is going to be added. Let's check this. The question says, find the quantity of boric acid in grams to be used in compounding the following prescription. So this prescription contains atropine sulfate. So we have atropine is sulfate, 1%. Then we have boric acid, sufficient quantity, which you are going to calculate. Purified water up to 30 ml. So adjusting substance here, as you can see, it is boric acid. You can easily witness that this is quite different from the previous questions which we have been solving, where we were using sodium chloride. This time we are going to use other tonicity agent apart from sodium chloride. What do we do? What we need to do, we need to go about 3 steps. But remember, first you need to understand the sodium chloride equivalent of atropine. The sodium chloride equivalent of atropine, this is 0.13. Okay, atropine sodium chloride equivalent, when you check the table, is 0.13. After knowing that, let us proceed. Step number 1, to find the actual amount of sodium from its concentration. 0.9 is in 100 ml. Water about 30 ml. So in 30 ml, what do we get? Which is 30 over 100 times 0.9. Then that is 0.27 grams. Step number 2, find the sodium chloride equivalent of these ingredients. Here we have atropine sulfate. So atropine is 1%. During the sodium chloride equivalent methods, we not use percents, we use the actual amount. So calculate the actual amount first of atropine. That is 1%. 1 means it is in 100 grams. So the all preparation of 30 ml contains how much of atropine? That is 30 divided by 100, probably that is 0.3. So this is 0.3. 0.3 multiply, 0.3 grams multiplied by its sodium chloride equivalent from the table, which is 0.13. Then you get 0.039. Step 3, subtract what you got in step 2 from that of step 1. 0.27 grams minus 0.03 grams. What you get? You get 0.231. Now if you check, these are this is 0.231 grams of sodium chloride. sodium chloride. But according to our requirements, our question, we were not after sodium chloride. We were not looking for sodium chloride because this time we used another tonicity agent apart from sodium chloride. So we are looking for boric acid, not sodium chloride. So boric acid, how do we figure out this? First, determine the sodium chloride equivalent of boric acid. Determine the sodium chloride equivalent of boric acid. So the sodium chloride equivalent of boric acid from the table is 0.52, meaning that 0.52 grams of sodium chloride can produce the same osmotic effect as 1 gram of boric acid. So if I have 0.231 grams of sodium chloride, then how much boric acid do I need? Just cross multiply. Then this is 0.231 divided by 0.52, that is 0.444 grams of boric acid. Okay, practically find where boric acid is in your laboratory, then weigh 0.44 grams of boric acid. Next, weigh how much? 0.3 grams of atropine. Then dissolve them in a total amount, in a certain amount of water, then make up the final volume up to 30 ml, and the preparation shall be already isotonic. That is the end of sodium chloride equivalent method. Let's meet in the next session. I'm Mr. Laidan.